Hi everyone, this is our second podcast session. With me today, I have Lauren, who's a data analyst, and she has 3 years of industrial experience and a lot of knowledge with the various Python tools, with various tools and various frameworks. She has constantly delivered a lot of promising results, be it from customer success, or be it at her current profession. So today I have her because of her background in bioinformatics, and that was something which caught my attention. And that will be the topic of discussion: AI and bioinformatics. So, hi,
Mhm.
Lauren. Hi.
Hi, Andrew.
Yeah. So, just to begin with, like AI, bioinformatics, two are such wide and distinguished fields. I mean, AI is completely technical. Bioinformatics is completely a different thing, is an amalgamation of technology and medical is something else, is entirely related to biology. So yeah, so begin with what exactly, I don't think our viewers exactly understand what bioinformatics is, and how is it different from medical industry. What exactly is bioinformatics? How do you distinguish it from medical industry? At least I don't know it quite clearly. So would you like to elaborate on this?
So bioinformatics is a subset of data science and healthcare. Bioinformatics specifically deals a lot with genomics, and we deal with things like evolutionary relationships based on genomics, and we deal with things like predictive medicine and personalized medicine based on genomics. So it's very gene focused right now. We're interested in DNA, RNA, proteins when we're talking about bioinformatics. But when we're talking about the larger topic of data science and healthcare, there's a lot more to be said. There's a lot of applications which are not so genomically focused, but things like streamlining workflow for people in the healthcare industry. That's a big application of AI in healthcare right now.
Yeah, I mean AI. So what my understanding with AI is something like you given the inputs, it tries to mimic my action or any human's action of the domain which we are talking about. So be it any domain. So it will try to mimic my action, and given the data and the outcome the human takes based on that data, based on that input, the outcome that the human takes, the AI is something like that. It tries to mimic it. But it's just a superficial understanding. But what is AI for medical industry is something of our interest for today's session. And so I would like to begin with how has been technology for medical industry, and how is AI, do you think how AI is like this was a technology for medical industry, and this is how we are about to change. This is the shift that is about to happen. So how do you visualize it? How do you think so? So what's the landscape of AI in medical industry, and how was it before? Before AI, I mean medical, there was a active involvement of technology. Medical industry is the progress of medical industry is caused by its technological invention. If I'm not wrong, I mean there's definitely a lot of medical industry is caused by its medical practices, but I think technology does play a major role.
Yeah, the technology has changed a lot in the past few decades. So we want to back up and talk about where it all kind of started in the 1960s, which is where AI really started to become a thing, with computer software expert systems, which were the first real attempt at mimicking the decision-making process of experts. So one of the landmark projects was called Dendral. It was started in 1965 at, where was it? I believe it was at Stanford. That might have been Meissen.
It doesn't matter.
That was
Yeah.
Meissen, sorry.
Okay.
Dendral is at Stanford.
I don't know. I don't know. Yeah.
Stanford by Edward Feigenbaum, Bruce Buchanan, Joshua Lederberg, and Carl de Gerasi, along with an additional team. And the specific task of Dendral was to study hypothesis formation and discovery in science. And they chose a specific task. They chose to help organic chemists to help identify unknown organic molecules. And the way they did that was by analyzing mass spectrum data and using expert knowledge of chemistry. So that program was written in Lisp, and at the time that was a very popular language in data science, but now we've moved on to things like Python and R.
Yeah, I mean, Python rules over data science.
Yes, but people really started talking about things like heuristics. Heuristics are rules of thumb.
Yeah. There was a lot of hype over heuristics. There was a lot of hype which revolved around heuristics. Yeah.
So this was the time when people were starting to think, can machines think? Can they mimic the decision-making process of humans? And what we found is that they can. But at first, it relied on a whole lot of expert knowledge kind of being hard-coded into the system. And people eventually got tired of the limitations of that. That was very expensive to produce. It required a lot of expert knowledge. And that eventually led to the AI winter in the 80s.
Another reason being that the traditional ML algorithms were performing at par with the neural networks. And when did convolution neural network happen? I think it was back in 98 or 2000s, convolution neural nets. When did it come into picture? I think it was in 2000s or something like that. I don't remember the date. Yeah, but in 80s, what are you talking about? The AI winter. It was in the AI winter. It was the contributing factor, which I know is one of the contributing factors was SVM performing at par with the neural networks. Yeah, that was one of the contributing factors, and yeah, that was one of the causes that AI came to a halt, and we didn't have enough competition pass. But after 2013, we saw immense jump of AI, and that immense jump was initially started with AI actively getting into the medical domains. So we are observing that AI is starting to diversify itself. We are seeing that AI is getting into marketing, AI is getting into automobile industry, AI is getting into what not is getting into telecom, is getting into I mean, everything is getting into everything. It's getting
into everything now, and that's partially because the ways that we go about it has changed. So there's been really early interest in the 1970s. It started being really interested in using AI for diagnostics, which is where we talk about things like Mycin, which was another expert system developed at Stanford in the early 1970s, written in Lisp. It was a doctoral dissertation of Edward Shortliff under the direction of Bruce Buchanan, who had worked on Dendral before. But the purpose of that was to identify bacteria that were causing severe infections, such as bacteremia and meningitis, and to recommend antibiotics. But it never actually went into production because it was a standalone system. It had a knowledge base of about 600 rules, and it would query the physician running the program with a long series of questions. And then at the end, it provided a list of possible culprit bacteria ranked from high to low based on the probability of each diagnosis, with some confidence intervals and the reasoning behind the diagnosis and the recommended course of drug treatment. So being a standalone system really prevented it from being actually used beyond academia. Physicians don't have time to go through hundreds of questions.
Still, a lot of things are still stuck in the academia, and few of the things get into production. I mean, by few, I mean really something gets into production. Something really gets into production. Although a lot of majority of the work which happens in the AI industry, majority of the research papers from which we get to learn new things are all revolving around the medical industry, be it unit, be it any kind of things, but the majority of the things happen on the medical data sets. So there's a fascination of the data scientist with the medical industry, or I don't know what it is, but you can see a lot of things which happen with the medical industry, but the fact that the research or everything is concerned with the medical industry, but a lot few things happen or make their way in the production. It might be the reason of the gap between our understanding. We as a data scientists, we do not have the domain understanding, or it might be the case that people who are in the medical industry, they are not welcoming the technical advances. They are a bit scared of what might happen, or it might be the communication gap, understanding gap, anything. Either it might be it might be the either they think that AI might jeopardize their jobs, or they might think that they are a bit uncomfortable learning something new at whatever they're doing. So it's also difficult to learn something new. That's not deniable. That's absolutely.
Mhm.
I mean, we cannot deny the fact that at all of a sudden we are asking a non-technical person to learn something not even technical, is something top of the technical industry. Now AI is leading the technical IT industry, so it's not the basics of technical industry. You need to understand it. Either if you're into it, you need to understand it in and out. So you cannot be
Right.
partially submerged into it. You cannot be partial. So it's not, you can't be like, I do AI for hobby. You cannot do AI for hobby. Either you do it passionately, or you just utilize as an end product client. So I
Mhm.
think there are multiple factors. How would you like to weigh in the reason that medical people are either not using AI or are unable to use AI? What
So
might be the reason?
we have a lot more promise in AI now with the development of new models like support vector machines and neural networks, which offer a lot of promise for things like diagnostics. A survey by KMPG found that some 47% of healthcare industry execs believe diagnostics will have a significant impact soon within the next 2 years. That's what they said in 2020. So 68% were confident AI will eventually be effective in diagnosing patient illnesses and conditions. There's some interest in automation of things like X-rays and CT scans. We're really seeing a huge growth in image analysis, especially when we talk about AI in healthcare. So you want to talk a little bit about the promise there and some of the headlines that have caught your attention?
Yeah, so I was recently going through the chip thing. So I mean, the chip thing I recently got to know. I think everybody knows that uh, what a neural chip is able to control a monkey's mind or monkey's brain, an animal's brain. Basically, that's what it is doing. On a trivial animal, it is able to control and direct the brain signals with the help of a chip. So that's quite interesting and fascinating. At the very same time, I was wondering that a few decades back, when the cloning was had an equal hype, so that was when bioinformatics was at peak. We had cloning, we were doing genetic mutations or different things, and the bioinformatics was at its peak. So
Yeah.
do we expect a similar fate to repeat? Do we expect a similar fate to repeat, that all the hype might be, and there's a hype around this AI getting into bioinformatics, that AI controlling human mind, AI might control human mind, or we might develop some sort of technology which might assist anyone, which might assist anyone to control the human mind, so the brain signals, heart signals, or whatever the technology is. At the same time, we might despise it. The society might despise it. So
Yeah, it can be a huge invasion of privacy, which is a big issue to talk about.
yeah, it's a huge invasion of privacy. I don't think it's a sustainable development. I think it's getting quite extensive development. We need development, that's undeniable, and that is inevitable. I mean, with the society progressing, even not the society progressing, we do need development, but development should be, there's a lot of need around in the medical industry. There's a lot of need, rather than controlling the people's minds or making artificial suns, although that is not bioinformatics, but that is also kind of that is what you're trying to do. And there's a lot already. Without the active involvement of bioinformatics, we can see a lot of things happening. We can see the bioinformatics in Singapore. You can see, people already know what kind of things happen, the genetic modifications and those kind of things. So the reason that people were against these kind of bioinformatics was the reason that that would eliminate what we call as the natural development or natural, or the what we call as heredity or evolution. That would eradicate, or that would nullify the concept of eradication. Also, that would nullify the concept of evolution. That would nullify the concept of evolution if we start developing as per our requirements. If we consider ourselves as the gods of human race, and we develop genes in accordance with our needs or in accordance with the money, or whosoever throws the money in. So where are we heading towards? Is it so gloomy, or can we expect the things to be rosy?
In the short term, I think we're going to see a lot of applications of AI in healthcare in pretty mundane things like monitoring blood sugar or predicting when someone's kidneys are going to fail, maybe before it actually happens. So that's kind of the immediate focus in healthcare, is augmenting what we already have. We want to improve patient access to care, which is a huge problem in healthcare. We have a very stratified healthcare system depending on your own personal means. And a lot of people don't have the access to healthcare that they need. And that's where AI could step in and start helping provide more personalized care on a more daily basis. So I think that's going to be the first thing for AI to tackle, is more mundane stuff, the insurance paperwork, the monitoring of chronic conditions, the response to crisis situations, when we may not be able to have a person available 24/7. Those are going to be the first things that we look at. But if we look further off in the future, then we start talking about those kind of more scary, privacy invasive things where we're concerned. We definitely have the ability to edit the human genome now in ways that we never could before. I personally was involved with creating a web software system for genetic editing researchers using CRISPR, which has been called the biggest biotechnology of the century, because we can edit any gene in any organism with pretty high precision. Precision was actually one of the first issues with it, and that's what my research was addressing. I was optimizing it for precision, so with the hopes that it can move on to clinical trials. Well, that's already happened now. We're seeing people's genomes being edited in clinical trials. They're using it to treat things like sickle cell anemia. They're using it to treat things like terminal cancers. They're using it to treat things like blindness. And these are showing really promising results.
These are quite promising, and these are rather fascinating. These are absolutely fascinating. If that's the good use of AI. I think that's what I would call as a rosy part of AI. But
that is the rosy part of AI, is saying, okay, how can we provide better healthcare with better predictive capabilities? Right now, we have a very we respond to things after they happen, but we want to in the future be able to predict healthcare events before they happen. We want to be able to say, oh, well, you're highly likely to experience a heart attack right about now. So what can we do to prevent that from ever happening?
Yeah, this is such an interesting topic. I was reading about this. It's glad that you brought this up. I was reading about this. I couldn't understand it quite well, but no matter what, I still read and carried forward. So it was about the predicting based on several factors, based on the kind of genes you have. Or I don't remember what the factors are, but based on several factors, an algorithm would predict at what age, what's the life expectancy what's the probability that you'll be affected by a disease, and what's the probability that if
Yeah.
someone takes the medicine, that someone doesn't take medicine, and if someone does the prescription, someone does not prescription, someone gets affected, someone does not get affected. So that was so such an elaborate way of mathematical and statistical study, and that's
Yeah.
quite impressive. So that's I think that's much needed in the industry. But
We want to be able to offer more personalized treatments based on people's genomics and metabolism so that we can give them better treatments that might work for them. Right now, people can go through multiple meds that fail and fail and fail on them because we don't know exactly which drugs they will respond to.
yeah,
And that's
yeah,
something that we could
absolutely.
address better in the future. We could have better ability to predict who might respond well to what drugs and who might respond well to what treatments. So that's a very promising area of research.
That's definitely a promising area of the research. And added to it is like the other thing that this will make the medical services quite accessible to a lot of people, to the lower strata of the industry, to the lower strata, or even in the general consultation. So if I have an headache, if I were to, it might be a it might be a serious cause, or this might be a simple headache, but you never know what it is. But I think with the
We
AI
need,
integration, with an AI integration, things might be better. Things might be better and better directed. Things might be better directed rather than being so haphazard and being. So diagnostics usually for a heuristic approach, they start off somewhere. Then there's a hit and trial, which usually happens at the beginning based upon the outcomes. So the conclusion is arrived at a much later point, at a much later stage, and I think that can be avoided with AI. That can definitely be avoided with AI if properly utilized.
yeah. So one of the big questions is how can we make doctors' time more efficient? Because I might be bold in saying this, but I think we don't have enough doctors in a lot of specialties for the number of patients that we currently have. Elderly care is a big one. We don't have enough people who are specialized in elderly care. We don't have enough mental health counselors for the mental health crises gripping the world right now. We need better access to patient medicine without necessarily having to go in and see a doctor. And the pandemic has really accelerated the growth of this field. We've seen an explosion in telehealth. Tell me, did you visit a doctor remotely during the pandemic? I know I did. So with that explosion of telehealth data, we're simultaneously seeing an explosion of all kinds of medical data. But integration is a big issue. So I talked about mycin not being ever used in practice because it was a standalone system. And we're seeing the same kind of problems crop up now. We need to integrate with existing sources of medical data. We need APIs to take data from those systems and make models out of them. And that's a big bottleneck in the industry right now, is having those APIs.
Yeah, so since you have touched this topic of challenges faced by industry, so why not elaborate on this? So challenges faced by the industry is also the data. I mean, the present data is accessible. However, the historical data, at least in India, is not accessible. Is badly maintained, is poorly maintained. The quality is bad, the maintenance is poor. So I think with the advent of AI and people's trying to understand and realizing the power AI can provide, I think now people are able to understand the importance of data. As what the data is, their data is finding the rarest of the rare, especially in the medical industry. Especially in the medical industry, data is about finding the rarest of the rare.
Right.
We
And that's a big data science problem. We need huge data sets in order to get a good enough sample of those rare events.
Yeah.
And we need high quality data sets. So that's a big bottleneck in the industry as well, besides APIs, is having those really massive data sets in order to train our AI models, because our models are only going to be good as the data they're trained on. And that brings us to the topic of biases in the models. We don't want our models to be implicitly racist, sexist, ageist. but that's definitely how it can end up with the data we have right now, because our healthcare system as it currently exists is kind of sexist, it's kind of racist, and it's kind of ageist.
Yeah, I mean,
And not to mention classist. Like I mentioned, your access to healthcare really depends on your means right now.
absolutely. That's one factor, that it depends on the what my means, or as in the, it also depends on the one who's developing and the one who's funding it, the funding the project. So the ones who are funding the project, I think it might be the case that they are dealing with it benefits if the model is biased.
Yeah. There's also issues of being able to deal with, for example, changing prevalence rates of diseases. The University of Minnesota partnered during this pandemic with industry giant Epic, and they created a AI model to predict whether or not someone would have COVID-19 based on X-rays. And they made it available for free to the hospitals in their network. Several have taken them up on that. But it has to be robust even when COVID is not such a huge thing anymore. When the prevalence goes down, this model still needs to perform well. And that's something that's a data science challenge, is accounting for those changes in prevalence. Flu season models are another one that have really taken a hit on that lately. With everyone wearing masks, the seasonal flu didn't even appear this year in the USA. So how is that going to affect modeling of the flu going forward? Have some strains of flu gone extinct? I don't think we know yet.
Yeah, yeah. That's an interesting insight. That's definitely an interesting insight. Added to it, I mean, the AI being harnessed in the industry, I don't think AI is being harnessed in the industry. We have done a lot of research paper on GANs, especially the GANs. If you read the GANs research paper, they talk about generating a lot of medical data. They can generate and harness medical data. And the problem is there's no problem with the 96 or 97% of the data. The problem lies in the 2 to 3% of the data, which is difficult to find and within the 2 to 3%, there's a lot of variation. There's a whole spectrum of data in the 2 to 3% of the abnormalities, the medical data is all about abnormalities. We need to find the abnormalities.
Absolutely.
Yeah. And
it's all about abnormalities. It's all about rare events.
It's all about the rare events. Yeah.
And that's data science issue.
That's a data science issue. And I did attend an expert. I did not attend an expert panel. I was listening to an expert panel, and they were talking about, although no matter what the progress has been in the AI industry at this point of time, but we are not confident to integrate it in the medical services. We are not confident that we can integrate in the medical industry. So that is so I think I wanted to understand why that might be the reason. Is it because that we as the engineers are we as a data scientist are usually come from engineering or pure non-medical background? Usually the data scientists majority of the data scientists come from non-medical background, and the medical people are bit wary of using technology. They are not comfortable with using technology. Or is it like they think that it might jeopardize their jobs? Or what is it? I really want to have
There's
an insight.
There's definitely hesitancy in healthcare to adopt AI, maybe more so than any other industry. Only about half of employees in the healthcare industry say that they are excited about adopting AI in their field, which is the lowest of any industry that they've studied. So there's definitely a lot of data hesitancy there. People are concerned. Privacy of data is one of the biggest concerns. Data leaks of sensitive data would be disastrous, would be a PR nightmare for whoever experiences that, but we can expect that to probably happen in the next few years.
But that definitely boils down to the organization. I mean, how organization feels responsible to maintain and store the data. Don't you think that? What's your
86,
take?
86% of healthcare industry executives say that they are taking steps to protect data privacy as they're implementing AI. Now, ideally, that would be 100%, but 86% is fairly good. People are definitely thinking about it. People are considering it. So that's somewhat promising. I think that there also needs to be a lot more data literacy. Like you said, people are kind of segmented right now. We've got our data scientists, and then we've got our healthcare professionals, and they've got different expertise, but we really need them to work together if we're going to make this work in clinical practice.
Absolutely, absolutely. That's the need of the hour. That's the need of the hour, because what I see is I had a conversation with few of my doctor friends, and if the moment I show that AI, I'm doing a project, this can automatically diagnose which one is healthy, which one is not. So people don't have a welcoming attitude towards the technology. They are they frankly are jeopardized by this thing, and which is quite normal. I mean, or they are not comfortable with regular technology, and AI is the topmost technology that is happening right now. That's the topmost technology that is happening in the computer industry, in the IT industry, and I think that is pretty obvious. So how can we bridge the gap? It is not humanly possible for any person to understand medicals as well as to understand the computers.
We need
There
to
might be
have more crossover training.
We need to have a more crossover training. That's absolutely.
We need to address fear of the unknown, which I think a lot of people are experiencing right now. Doctors, if they're going to use these models in practice, they need to know about the biases of the models. They need to know about where they can go wrong. They need to know about errors they can make in clinical practice. And if they don't know that, if they just take the model as gospel, we're going to run into some serious problems.
Yeah, absolutely. And added to it, I think what I think is the apprehension that AI might lead to unemployment can be diverged into AI can lead into unemployment. It can lead to underemployment, wherein the case of underemployment, it will be the case where handful of the people are being paid handsome amount of salary and rest are being unemployed. Or it might be the case of overemployment. In my understanding, I think if AI is implemented properly, not for sole capitalistic needs, if AI is implemented properly to assist the humanity or to assist the human race, I think I mean the fear which people have, the fear the medical people have with the AI thing being integrated in their system is might be the reason that they think it might jeopardize their job security, their work, or they think that they will be replaced by bots. Or I don't really understand. Nobody does really understand how it would be, because neither of us has seen what the future holds for us. But uh, we can always expect the better things to happen, and I think it might lead to overemployment rather than unemployment or underemployment. Initial phase might be a bit bad and glooming. It might be a phase of unemployment, but after that, I think it might be a phase of overemployment. That has always been the case of history. No matter how the wheels of history have turned, we've always seen that there has been an overemployment. Be it after the Great Depression of 1929, most of the people switched from from being farmers to something else, from different jobs. So after the Wall Street crash and after the Great Depression, most of the agricultural economy got shifted, and not the agricultural economy, the most of the agricultural sectors got shifted to something else. So I mean that's the essence of human race. That's the essence of human race. We knowingly or unknowingly, we subconsciously keep on evolving ourselves, and in the process of evolving ourselves, we keep on reducing, as you just said in the beginning of the session, we keep on reducing the mundane tasks. We try to avoid the mundane tasks. And I think the best example, which I quote again and again, is the archery example. Archery, being such a skilled profession, needs high level of skill. You need to pull the arrow out of your bag, then stretch the string in the right amount, place the angle in the right amount, measure the wind, everything. There are a lot of factors which come into the play. The strength, the way you deliver should be correct. But when it now it has evolved to gun and the bullet, the things are much easier and better. No matter what, there are still
Mhm.
archery competitions. There's still the gun aiming or the shooting competitions. We do have them, but the thing is, the skill is now available to a lot of people. The skill is available to a lot of people. So there was a small percentage of people who were there in the war field who acted as archers. Now everyone is a kind of is a modern day archer. So that
I
is
think
something interesting. So that is what I think. The medical industry, if medical industry gets integrated with AI, I think we can expect the missing gap between the number of patients we have and the number of doctors we have.
right, that's a big issue. We just don't have enough doctors, especially in certain specialties, for the number of patients we have. And doctors are overstretched right now. And right now, you go and see a doctor and they have like 15 minutes to speak with you, to listen to your problems and try to identify a best course of treatment. And the rest of it is stuff like paperwork, insurance paperwork. How can we free up doctors' time for more patient interactions to get a better picture of how people are doing and how we can best treat them? I don't really think that automation is going to take away jobs in the healthcare industry. I think that that is kind of an overblown fear that you're going to lose your job to a robot. We still need those patient interactions. We need that human touch in the healthcare industry very, very much. People don't want to just have their doctor replaced by a faceless algorithm telling them what to do. At
Yeah,
least that's my
absolutely,
impression.
absolutely. Yeah.
I do need to amend my statement earlier that I said half of healthcare employees support AI adoption. The figure is actually 67%. So about 2/3. That's still the lowest of any industry, like I said. Overall, in other industries, people are more excited about it. But it's definitely going to be a thing. I think it's going to change the nature of how people work in the healthcare industry. I think that it's going to, as we were talking about, help relieve some of those more mundane tasks and help people focus more on the human connections, which is going to be a really positive change, in my opinion.
Yeah, and I think the integration might also act as a validator. I think the role of AI, which I
Yeah.
mean, we cannot deny the fact that AI is not anything which is standalone. AI is nothing if it is a standalone thing. AI adds its meaning of value the moment it is integrated or amalgamated with something else. If it is a standalone thing, it's useless, it's baseless, it's void, it's null, it's nothing. But the moment it's integrated or amalgamated with something else, it adds its value. It starts to add value to what the sector was already, what the sector had already done. It adds value to it. So I think like the kind of the banality which exists, the mundane tasks which exist, AI would definitely would alleviate the boring task and would add a way to expedite the process. So the things which took 3 days would happen in few hours. I think that's what we can expect. That's what we can expect. So radiologist, we can, so the things that we see on the internet, the data sets are there, different data sets are there. So the people, the apprehension which comes first on the top of the head, like is if AI is able to automatically detect if there's a cancer or not, or if there's the whatever it is, the abnormality or not, are we as a radiologist going to lose our jobs? No, that's not what I
Because
know.
radiologists
Yeah,
do so much more than that.
yeah,
They are
yeah,
not, they are not a single task. They don't just tell you, does this x-ray look cancerous? That is not the sole job of a radiologist.
absolutely,
Um,
absolutely. Yeah.
so, but we do need a lot more training on AI in healthcare. Only about 47% of healthcare execs say that their org currently offers AI training to employees. So there's a big gap there in terms of getting people up to speed with what data science can do in their industry and how it's going to play a role in their lives.
Yeah, and I think so. Wrapping up this particular session, I think the reason that we are not able to integrate the medical industry and the AI industry might be the consequences of the decisions it takes or the person who is responsible for it. So how do you weigh it? I mean, we cannot blame the algorithm. Anything we cannot blame the algorithm, or it's not even justified to blame the creator of the algorithm until and unless it is commercialized.
So it's easy for us as data scientists to get really excited about this field because we have so many tools at our disposal. We have so many algorithms now. We have so many machine learning tools that offer so much promise in so many different areas. But if people don't know how to use them, then they're going to go to waste, is essentially the big issue right now that I'm seeing.
Yeah, and I mean, ML models, we still have some kind of features. You can find what were the coefficients of the basis of which the prediction was made. But I mean, you can understand what are the coefficients, the features are being provided, what are the importances, the features are being provided. You can use SHAP method to understand what was the inference based on how the inference was reached. This is for the tabular part of the medical sets or medical data sets, but there's a huge chunk which is the image part, and it's actually impossible to justify by an ML model how did we reach to the conclusion. ML model is able to reach conclusion at a much faster rate, and we did realize few years back when I went across a news article wherein a group of radiologists were made to compete against AI algorithm. AI algorithm was able to achieve 87 or 86% performance at a much faster rate. So it was able to outperform in the speed as well as in the performance, in the
Right.
efficiency.
So machines are able to see things in images that we might not be able to easily see with the human eye. There's a lot of untapped information in medical imagery that is just beyond what human expertise can really cover. And that's where computers can be really, really helpful. They can help point out features that we would have never thought to look for before.
Yeah,
So a
even
lot of the
after.
major advances we've seen in AI lately have been focused on image analysis. That's a really big topic right now.
Yeah, image analysis, the natural language process analysis, data analysis is also taking a lot of heat in the moment. So I mean, all the insurance claims, there's a lot of work which goes in the tabular data sets for the by the insurance companies, as also for the understanding what we were discussing few minutes before, the medical industry, the understanding life expectancy, the understanding predicting whether or not the chances of any disease happening in few years. That is
Oh, for sure. Insurance companies are very interested in things like life expectancy, predicting when bad events are going to happen.
Yes. That is entirely data
That's
analytics. So I think there's three fields need an active involvement. Three fields will have an active involvement in what we see as the future, what the future holds for the medical industries. The three fields actively involving in the medical industry. But what my concern is, we're talking about the ethics, the laws, the things, the governing body. So the governing body is, I do not see anything which is governing at the moment. What the thing is there in the European Union is the data privacy laws. Data privacy is one aspect. It's one aspect. Okay, you are preventing the laws, but how do you prevent the models from taking action? Or how do you? So I think that might be one of the possible barriers, that AI is not being actively integrated, and the moment it is, the reason it is not integrated is might also be the reason that people uh, are not appreciating the value AI can bring on the table. What's the take?
the legal status of AI in healthcare is still in a state of flux. There's a lot still yet to be decided about how we're going to regulate these things. We do know that they're going to need ongoing monitoring. It's a big investment to take on AI. And that's actually probably one of the biggest factors preventing implementation right now. Around 54% of healthcare industry execs say AI increased the overall cost of healthcare. And that's obviously, we don't want that. Here in the US, we're already paying the highest rates for healthcare in the world. And when we're saying something's going to make it even more expensive, that turns people off pretty quick.
Yeah, absolutely. That does turn, but the reason, the thing is that does definitely does the expenses all inevitable. The expense of integrating a new technology is inevitable. I think that will get reduced with the passage of time. I mean, any new
Yes.
technology is expensive at its advent, but with the passage of time, the more common it becomes. I mean, memory sticks was so expensive a few years back, and now it is so inexpensive.
Oh,
So
absolutely. I
so I
mean,
think technology
with
depends on the technologies, the time the technology has, the maturity of the technology, and definitely because the expense is majority of the expenses due to the research part which is happening, because a lot of research goes into the waste, and a lot of that's what why it's expensive. So I think that needs not to be feared. I think the expense can be lowered, or I mean, ultimately depends on who's controlling the things, but I would definitely expect the expenses to get lowered. Yeah.
yeah, I'm definitely also expecting expenses to go down, but we're still kind of in early stages right now. And right
Yeah, I mean,
now,
a normal
if
consultation,
you want to be an early actor on this, it's going to cost you.
yeah, it's going to cost me. It's definitely going to cost me. And I ultimate goal is a simple consultation should be accessible. That should a simple consultation, even in the remote areas, should be accessible to to the remote, to a lot of people. I mean, no matter where you live, no matter how you live, no matter what the situation is, AI should assist the consultation, at least the trivial parts or the banal or the bland part of the medical industry. That would be a great success. Added to it,
Yeah,
what I consider a success is assisting radiologists rather than replacing radiologists. Although replace
absolutely.
the prospect of replacing radiologist with AI is
That's really the
baseless.
theme right now.
Is
It's not replacement of people in healthcare.
yeah, it's
It's
baseless. It's baseless.
assistance.
Yeah, it's baseless. I mean, it's absolutely baseless. You cannot replace with AI. You cannot replace
Mhm.
anybody with AI. So that is at least not at this point of time. Yeah, I think we definitely had a good conversation, and I would like to have your ending thoughts on the ultimate direction we are heading towards. So, I mean, we have seen many great things. The rosy thing might happen. So many great things can happen with AI. We can expect great things to happen, or it might cause the doom which nuclear power caused. A nuclear power did cause something bad. We cannot deny that.
Yeah.
Yeah. So I mean,
So
I mean,
I'm going to end with a quote from Mitali Dutta, who is head of data science and predictive analysis at Philips Innovation Canvas. She spoke at a session in the Rising 2021 by Analytics India magazine, and she said, interoperability and integration are the key factors that separate academic research from practical applications of AI. So that's where we are right now. We've got a lot of academic research going on that shows a lot of promise in things like diagnostics and things like workflow optimization. But in order to actually make this work in healthcare, we've got to overcome some major challenges in integration with existing systems.
as well as we need some good governing laws that ensure the better utilization and proper utilization, controlled utilization rather than destructive utilization.
On ethics, the White House has been calling for more transparency in our system. So a lot of our newer models that offer such great predictive capabilities are what we call black boxes. They don't offer really easy interpretation that is good for justifying diagnosis and treatment. So there's this conflict between opaque algorithms and the need for transparency. And that's another issue that's going to be ongoing. Where do we use more transparent models?
If I can get my job done with an opaque model, rather get my job done at a faster and a better rate, should I really concern about the opaqueness or the transparency, or should I concern who is developing it and who should be held responsible? I think the prime concern should be, yeah, if I can
The
get
question
my,
is who's going to be responsible?
I mean,
Who's legally going to be responsible?
it's not. So I mean, we have been trying to discover who made oxygen, who made sun, who made water, who made what and whatnot. But those questions, some of the questions are better not to be answered, rather than focusing on the main thing: how to preserve water, how to preserve air, how to preserve these things. So I think the main prime concern is, rather than transparency of the models and interpretability, I think the prime concern is regulations. We do not want the models to go unregulated and the power to be limited in the hands of the few, so that it goes
Right.
exploitative, it goes biased, it goes in a, we don't want things to go in a destructive manner. We, at least we as a data scientist who have devoted so our love and passion for science in such a novel thing, we want it to be a good thing. I mean, at the end of the day, we want the better of the humanity. We don't anything bad to happen. So
the question is really going to be, are we going to let a single company or a handful of companies know all of our biometric data just so they can make better predictions? Or are we going to take a more democratized approach, which is going to present its own challenges if it's more distributed? But we do probably want to avoid big monopolies in healthcare. I mean, think about Google and how much of a role they play in our lives now. Do we really want to hand over all of our medical data to, say, Google too?
Google is already hampering a lot of does definitely mislead with the medical guidance it provides. I mean, nobody trusts Google's on the medical diagnosis.
Yeah,
yeah,
they might
absolutely.
have data science knowledge, but do we really trust them? Probably not.
No, nobody does. So that's the problem. So let's end the session here. And that was absolutely brilliant session. And it was a great pleasure to have you on board. And
Yeah, thanks for speaking with me.
Yeah, and being a data analyst as a profession, it does reflect in your communication or whatever it is. And I could understand you pointing the facts and figures at every moment and justifying the things in a very clear and lucid manner. It was a great honor to have a conversation with you in my podcast session. Let's hope for future collaborations more and more.
Yeah, I'm looking forward to it.